All right, let's take care of 14.2 now. So now that we have all these rocks moving around on the Earth's surface, let's talk about them a little bit more. So first of all, you learned about this years ago. I'm quite certain of it, but let's talk about that. Just a quick review of it. So when it comes to rocks, there's actually three kinds. There's three types of rocks out there in the world that we can look at. There's igneous rocks, sedimentary rocks, metamorphic rocks. Igneous rocks are rocks that come from lava and magma, melted rock that has then hardened or solidified. And there are three examples right here for you. This is granite, which is a common one, pumice, which is a decently common one, and so is basalt. So that's one basic kind of rock. The second kind of rock is sedimentary rocks. Sedimentary rocks are made from sediment, or little teeny tiny pieces of rocks like sand, silt, gravel, things like that, that have been fused or stuck together. And so these kind of rocks, examples, sandstone, limestone, and shale. Sandstone comes from sand, shale comes from mud, limestone comes from actually the shells of creatures like in the ocean. And then metamorphic rocks. Metamorphic rocks are either one of these two that have been altered by heat and pressure. So if I take a sedimentary rock and I apply heat and pressure to it, I can make it metamorphic. If I take an igneous rock and I apply heat and pressure to it, I can make it metamorphic. And so examples of that, slate. Slate was once shale, actually, that was put under heat and pressure. Marble, which was once limestone and put under pressure. And quartzite, which was once sandstone and put under pressure. But there's other examples. If I take granite and put it under pressure, I get gneiss, things of that nature. So metamorphic rocks, sedimentary, and igneous. And they happen, and rocks can move from any one of these to any other one of these in the rock cycle. So if I put any rock under heat and pressure, it'll become metamorphic. If I take a metamorphic or an igneous rock and I weather it or break it down, it can become a sedimentary rock. And if I take either one of these two rocks and I melt them, I can turn them back into an igneous rock. And so all of them work in concert and they interact between the three of them. It's important to know that this cycle, you've learned about a couple cycles in this class already, this cycle is by far the slowest of the Earth's cycles. This is a process that takes millions of years in some cases. On to section 3. Okay? So let's specifically talk about how this starts to apply to humans and human interactions. Rocks are made up of pieces of smaller things. So rocks are a combination of minerals. So minerals are a pure substance. They're naturally occurring, that's important, inorganic, not from a living thing. They have to be a solid, and they have to have a definite chemical composition. You have to be able to write a chemical formula for them. And then they have to form crystals. So, excuse me, all of those things come together to define a mineral. And so there's lots of examples of minerals, and we'll get into those in a little bit. But if you take two or more of those and put them in combination, you get rocks. So humans really like the mineral pieces. They take rocks and turn them into minerals. So that's where mineral resources come in, or ore. This is a bunch of rock and stuff that has the mineral we want inside of it, and it's something that we can extract that mineral from at a decent cost, an affordable cost. And so these mineral ores or deposits come in lots of variations, from a high-grade ore, which means it has a lot of the mineral we want, to a low-grade ore, which means it doesn't have very much of the mineral we want in it. But we keep in mind all of these things. So what are some examples of minerals? First of all, it's important to know that these minerals we talk about are non-renewable. Okay? Once we use them up, there's no more on the planet. They don't make new ones. A lot of them actually are only made in supernova explosions. They're not even made in our sun, for instance. And so there are non-renewable metals and non-metals. So they can be either one. But examples, aluminum. We use it for all kinds of goodies. Steel. It's actually iron ore, and then we put other elements into it to make steel, but nonetheless. Copper, platinum, gold are all examples of metals that are minerals. And then sand, limestone. And then here's some other delicate ones that we use. These are also metals, by the way. And some of the uses. And so you can see that we're using minerals for all kinds of things. We actually use Each person in America uses thousands of minerals a year, whether you know it or not. And so here's the actual breakdown of how much of this stuff we actually have in our crust. So the most prevalent mineral in the Earth's crust is aluminum, approximately 8%, followed by iron. And so these are the two most common that we find. And so they're a little easier to get. They're less expensive. These ones are usually typically more expensive because you see that there's far less of it. That's titanium, nickel, zinc, copper, lead, uranium, silver, and you see how precious gold is, how rare it is, and why it's so expensive. So, when we talk about these minerals or mineral resources, we classify them in one of 4 categories. Identified means we know where they are, we know how much it is, we know how good it is, and there's direct evidence to show us. So this is stuff we can really trust. We have undiscovered mineral resources. This is places where we have potential supplies that are assumed to exist, but we don't know if they really do or not. We have reserves. Reserves are what we identify as minerals that we have identified, we know that are there, and we know we can get them out profitably, which means we can get them out at a good cost. And then there's this category of other, and these are all kinds of different things. They're undiscovered or identified resources that are not classified in any of these other things because they don't know if they're profitable or they don't know the quality of it or whatever it may be. So once we pull those minerals out of the ground, the way we process that is we pull them out, say using surface mining. It's not the only way to get it out. Then we have this metal ore. We take it and we separate it from everything else. The gangue is the term, and we'll talk about that in a little bit here. Once that metal has been separated out, the ore has, then we smelt it. The smelting it gives us melted metal that we can then convert into products. Once we're done using the products, we have a choice to either throw them away or recycle them. And this is the typical life cycle of a metal. So there's a process of extracting, processing, and using of these things. And that process has a huge environmental impact. We have to be aware of it, how we can minimize that impact. So it's important for us to know that that process matters, and we need to understand how we do it, but we also need to know about the quality of ore we're working with. Remember, we have low and high grade. If you're using low grade ore, it's going to take you more energy, more water. It produces more waste. It's just harder on the environment in general. Excuse me. And so what kind of degradation does it cause? Well, depending on the step, it causes its own degradation. So if you're mining it, that's exploration and extraction, it can cause all of this stuff to happen. None of it's good. During the processing phase, which is transportation, purification, and manufacturing, it has its own set of environmental impacts. And then while we're actually using it and throwing it away, it has its own other set. So you can see there's several different things that cause environmental degradation when we talk about the process of removing and using mineral resources. That's it for now. Bye.